Hi everyone, welcome back to the AI language. So today we are going to do something pretty amazing. We're actually going to add a user interface, as you can see over here, to our Python-based MCP client that actually works with MCP servers. We're going to do this with Streamlit, and you can see that UI on my screen right now. Before I begin, I would request you to please subscribe to our YouTube channel, The AI Language. This will also give you free access to all our code base and the MCP client UI that I'm just going to discuss. So before we begin, let's have a look at the user interface and what we are going to build in this particular video. So this is how the overall user interface looks. There's a main area for the chat and a sidebar over here. This is basically the user interface for our MCP client. The client is built using LangGraph's React agent and uses Gemini's API as the large language model, and it's written in Python. The UI is built using Streamlit, and this basically is the entire client. Let me zoom in to show you the different components of this particular client. We can collapse the sidebar from here, and you have the title over here with the logo, and you have a subtitle where I've just put a subscribe link to our YouTube channel. There's a section where the chat comes in and you can see the messages sent by the user and the response from the MCP client. Then there's a chat box to put your query, and you can press enter to simply submit your query for processing, or you can press the send button. You also have a new conversation button to start a new conversation, and you can save the conversation by clicking on save conversation over here. You can expand the sidebar by clicking this button, and then you have some settings over here. So you can select what kind of MCP client do you want. So you can either have an MCP client that actually connects to stdio servers, which are basically Python and JavaScript scripts that run locally on your computer, or you can use an MCP client that can connect to a server over the web or the HTTP protocol, which uses server sent events as the transport protocol. I have included the code for both of them, but the SSE code is not fully implemented yet. You can actually use it as a placeholder or a starting point if you'd like to. When we select the stdio server, you can actually upload a config.json file with all the MCP servers over here, and you can click on browse files to do that. Otherwise, the system uses a default config file, which is the AI language _config.json. You can see the historical conversations that you have saved over here. These are saved in a conversation folder with the timestamp at the end of the file. There's also an expandable log output block over here where you can actually see the entire log for your MCP client and server interaction. All right, so let's preview how this works now. So we press new conversation to start a new conversation. So let's first type hi and press enter. Now you can see that it's basically running it in the background, and we get the response from MCP, hi there, how can I help you today? So I'm using user to tag the messages from the user and MCP to tag the response messages from the MCP client and server. All right, so now let's write a query, create a file streamlit _success.txt with the text streamlit success using the run command tool, and press enter and see what happens. Again, it runs the query. Okay, and we get the response that I have created this file streamlit _success.txt with the text streamlit success. So let's check this out in the Finder window. All right, so this is the Finder window with the workspace for our terminal server, and we see that we have a file called streamlit _success.txt right over here. Let me open this file now. Okay, and you can see that it has the text streamlit success inside the file. So this means that our client and server are working well together with the UI. All right, so you can also basically click on save conversation over here, and this is basically going to save the conversation. You can click on new conversation by clicking this button over here, and this is going to start a new conversation over here. Now when you actually click on this sidebar over here, you have the option to load conversations. So let me just load this particular conversation, and this is the latest conversation that we just saved, and you can see that you have all the entire message history over here. Now for the MCP client Config.json file, you have the default file, the AI language _config.json, which is basically in the same directory as the application. In case you want to provide your own file, you can click on browse files over here. You can choose a file, and it will basically replace the content in this AI language _config.json file, and then your client is basically going to use that file. You also have an option to change to a different kind of MCP client and server combination, which is SSE. So SSE stands for server sent events. It's a transport method that is used by MCP clients to work over HTTP. I have provided some placeholder code for this, but this is currently not active in this particular client implementation. You can have a look at that code and modify it for your needs if you need to. I've just worked with the stdio client over here. So this is basically to show how you can actually build an MCP client, and this is like the first step. To build an app of a magnitude like, let's say Cloud Desktop, which is also an MCP client, one would need to actually include a lot of features to have a wonderful user experience. But this is just meant as an educational code to show you how you can use Streamlit to build a basic client UI for your MCP clients and servers. Alright, so to get the code for the UI, the client and the server, you can actually refer to the links in the description and the pinned comment. You'll see that right now we are referring to the MCP client folder where we have all the clients that we have previously implemented if you have followed through the previous videos. Over where we have three different files of interest. So one is the Streamlit client UI.py file. This implements the entire Streamlit UI, and this connects to the different client implementations above this file over here. So we have two client implementations for now. One is the stdio client implementation. Again, this is basically all the servers that you can actually specify in your config file, and these run locally on your computer. You also have an ssc.py implementation, which is right now just a placeholder for you to use and implement further if you actually want to work with this. For now, I'll be covering the UI file and the stdio server file. So let's go through the Streamlit client UI.py file code walkthrough and setup together. So to begin with, we have the imports, and I've added very detailed instructions throughout the code for you to help understand what each line means, and also the install instructions. So Streamlit is the core library that we use to build the UI, and we import it over here. Then we have async IO for async processes, especially for the tool communication, and we import it over there. We have OS, which basically provides file system interactions, and we have JSON to read and write the conversation data to JSON files. We then have datetime, which is used for timestamping. We have nest async IO, which you can actually install by typing pip install nest async IO. And this basically allows nested use of async IO event loops, and this is useful in interactive notebooks or Streamlit. Then you have the Python image library, and this is used to basically style the images like the logo in our tool, and you can install it by typing pip install pillow. You have the HTML components for basically more advanced customization, and this basically completes all our imports. So then you have nest underscore async io.apply. And basically in Python, when you use something called async or await, you're telling the program that do this task in the background while waiting for other things to finish. But Python normally only allows one event loop at a time. Streamlit and Jupyter or tools like them already use an event loop in the background. So if your code tries to create or run a new one, Python throws an error. So this line is like saying that, it's okay, let this new event loop run inside the existing one. It's like nesting one loop inside the other. So this basically patches Python's async IO, so you can safely run nested event loops, especially useful in interacting environments like the client that we are building with Streamlit, or things like Jupyter notebooks, or even REPLs that have already a running loop inside them. Now you have the app session state initialization. We have a conversation list. If that's not already present in the session state, we initialize that with an empty list. We have a client config, and again we initialize that as stdio, which is the type of the client. This is extendable to different client types. So you can basically include categorized clients over here. You have a server URL for SSE type of clients, and you have a stdio config file for the stdio type of clients. Then you have a placeholder for a reusable client object. So if client instance is not in the session state, we basically assign it to none, and we'll basically initialize this later on. There is a theme for toggling dark mode. I was trying to include this in the code, but I ended up not including it. But if you had to, you would store that in the session state. Then you have the logs, which we saw in the log block, and we initialize that to an empty list. Alright, so then we have a submit triggered flag in the state, and this is just to identify that if somebody is submitting the query in the chat box by pressing the enter key rather than clicking the send button. Then there's a flag to prevent infinite reruns of the loops after processing a query. So it's a query executed flag, which is initially false, and that's what we set it to. We'll use it later on. And there's a pending query string to actually hold the current query to be executed after submission. So again, we'll look at the usage of these state variables as we go along. So then we have some utility functions, and the first one is run async in event loop. So this function is like a task manager for background jobs, or also known as coroutines. Normally, to run an async task in Python, you need something called an event loop, and it's like an engine that handles multitasking, but Streamlit already runs its own engine. So if we try to run our own separately, Python gets confused. So what this function does is that it checks, is there already an event loop running? If no, it basically creates one. And if yes, it politely asks the running loop to add our task to its schedule and waits for the result. Then we have the add log message. So it's a logging utility that logs the messages with the timestamp to both console and UI logs. So this function is like a note taker or a diary. So every time something happens, like receiving a message or processing a query, this function writes it down. So it adds a timestamp so we know when it happened. It adds the message to both the screen, which is in basically the Streamlit state, and the console, which is basically printing it on the console. So this basically will help you in debugging, tracking events, or just seeing what happened when. Alright, so then we have the sidebar for the settings and the log view. So this line with st.sidebar, this creates the sidebar panel on the left side of the Streamlit app, and everything inside this block gets displayed in that sidebar. So it's like saying that, whatever we are adding over here is basically stuff added to the left-hand menu. Alright, so st.header settings adds a section header labeled settings at the top of the sidebar. So this basically shows a radio button that lets user select between stdio and sse. The selected option is stored in the session state under the client config as client type, so it can be used later. And we use add log to basically log this selection, which shows up in both the terminal and the UI. Alright, so then we have the stdio config.json, or the fallback to the default option if we don't provide a file. So what we do is we basically upload our config.json for stdio using a file uploader. So this basically adds a file upload option where the user can upload a .json file. The JSON file is expected to have the config for the MCP servers, and this is used later to connect to the backend tools. So if a file is uploaded, we save it to disk with the name the AI language _ config.json. This acts as a standard config file your backend code expects. So if the file is uploaded, we basically store it on this path, which is in our directory over here. And we'll actually open this file and save it. Then we'll set the client config stdio _ config with this path. And we'll also print a success message and add log and add this to the log. If a file is not uploaded, we'll basically use the default file, the AI language _ config.json. And just after a basic check, if that path actually exists, which it should because we already have the file over here, we basically again set it to stdio config in the session state, and we add a log statement around that. If just in case this file is not present, we'll actually provide a warning for that, and again add that warning to the log. Alright, so then we have a section on loading the conversation. This is basically a horizontal divider, and then we have a header with the title load conversation. So we then set up our conversations folder or directory, and we actually make that. If it already exists, that's okay because this prevents any kinds of errors because of that. Then we list all the files from the conversation folder. And if we do find any conversation files, we basically go through each of these files and we get a file path. Then we open the file in read mode and we load the JSON from the file. We load a preview from the first 20 characters, in case you want to show it. And then we add a button to load this particular file name. If the user clicks this load button, the conversation is stored into memory and the session state.conversation is set with that value. And then a success message is basically shown on the UI and it's also added to the log. And if no old chats were found, we basically then provided information that we don't have any saved conversations at this time. We finally have again a section divider, and then we have a logs viewer, and this is basically a text area with all the logs from our session state logs. Alright, so next we have the main chat UI, and on the top of the chat we first render the logo and the title. So call 1 and call 2 basically splits the top of the app into two columns, and column 1 is basically 1/7 of the total width, and column 2 is basically 6/7 of the total width, and this is basically used for the title and this is used for the logo. Alright, so for column 1 we will load the image that's present at assets/logo.jpg, and you can go and see that we have an assets folder over here with the logo.jpg file over here. Then we take the smallest dimension, height or width to make a square crop, and this will basically help us make the logo circular. So this creates a circular mask, a white circle on black background that will apply to the image to make it look round. Now this crops the original logo into a square and applies the circle mask as alpha or transparency. Anything outside the circle basically becomes transparent. And this then finally displays the circular logo in the first column using full width of its container, and that's how you see the circular logo on the top. Alright, so then you have the second column, and over there we basically show our app's main heading in the right column. Okay, so for a subtitle, I use a YouTube call to action as a clickable link, and this is basically what we do over here. The unsafe allow HTML equal to true basically allows us to use basic HTML formatting like bold text, and the markdown formatting is basically used to style the link. Then we show the past conversation. So we basically loop through all the previous chat messages stored in memory. We get the timestamp, we get the sender, and we get the message. And then we display it in bold using markdown format using this particular line and in this particular format. Then we have a callback function that sets the submit triggered flag when enter is pressed. So this function is called automatically when the user presses enter in the box. So we first check if the input isn't empty. So if it's not empty, we set the submit triggered flag equal to true to indicate that a query needs to be processed. So this just means that, and then we copy the text to the pending query so we can use it after Streamlit loads the app again. Alright, so then we have the input box. So this basically renders a single line text input. The label is your query. When the user presses enter, submit on enter is automatically called, and the input is basically stored in query_input inside the session state. The placeholder text that we use is type your query here, and this is that input box. Then we have the 3 action buttons for sending the query, a new conversation button and a save conversation button. So the send button basically submits the query to the MCP agent. The new conversation button clears the chat history and starts afresh. The save conversation button saves the current chat log as a .json file. Alright, so now we have the core logic for query handling, and first we have this function. So this is an async function that sends the user query to the backend via stdio and returns the response as a string. We add a log entry that we're using stdio mode. Then we attempt to import the run agent function from Streamlit client stdio. So this is the implementation that we have over here, and we'll go through this later on. And we handle any kind of import error if it happens over here, and then we basically run the agent with the query that we imported over here and the query that we have received over here, and we get the result. We add a log saying that we have processed the query, and we return the result. So then we have the handle query function, and this function basically handles the full life cycle of a single message. The user sends it, we send it to the backend, and then we display the response. So if the user types quit, we reset the conversation to an empty list over here, and we log the same. Otherwise, we get the current time to timestamp the user message. We save the user query in the conversation history and we log it over here. Then we send the query to the backend using the function that we just looked at, and we wait for the response, and we are using the stdio client over here. Then we save MCP's response over here. This is the assistant's message basically, and we log that too over here. Then we set query executed equal to true so that we don't keep on rerunning this query on each reload, and this basically helps us prevent infinite loops for running the query. Now we have the main trigger logic. So if the user has clicked on the send button or the user pressed enter in the input box and the query hasn't already been executed in this cycle, that is the query executed flag is false, we grab the query from the pending query in session state. And if the query exists, we basically run the lifecycle for the query using handle query, which we just looked at, using this helper that we looked at in the beginning, which runs async code inside Streamlit. And then we reset this flag to false so that the next keystroke doesn't re-trigger it. Then we rerun Streamlit app after query completes to refresh the UI. So if the query executed is equal to true, we will reset it to false so that we can basically set up for the new query, and we force a UI rerun using st.rerun to refresh the screen and show the new chat messages. Then we have the new conversation button logic. So basically clicking this clears the entire chat history and logs it, and then it reruns the app to reflect the empty state. Then we have the save conversation button. So this is basically going to help us save the chat to a file. We basically make sure that the conversations directory exists over here. Then we create a timestamped file name using this particular statement. And then we provide a path with the conversation directory and the file name joined together. We open that file and then we basically use JSON.dump to dump the conversation over there. We then basically add a log regarding, a successful save, and we also show it on the UI. So this is our entire Streamlit _client _UI.py file. Okay, so now let's look at the Streamlit client stdio.py file that we're actually using to run the agent inside the MCP client. This is basically the LangChain MCP client with config agent. So if you've already looked at that particular lecture or video, you can actually skip this explanation. Otherwise, we're just going to quickly walk through the concepts over here. Alright, so this file basically implements a LangChain or LangGraph based MCP client. It loads the config from a JSON file which is specified by the AI language config variable, environment variable, and if you don't find this, it basically falls back to the local file over here. It connects to all the MCP servers that are defined in the config, loads the available MCP tools from each connected server, and it uses the Google Gemini API via LangGraph and LangChain to create a React agent with access to all the tools. Then it runs an interactive chat loop, so you can actually independently run this file as well, but we are going to use it with our client UI. Alright, so then we have the regular imports that we have looked at earlier when we have been designing our clients. So we have these imports for async operations, environment variables, etc. We have the MCP client related imports for managing the MCP client session and server and for establishing a STD-IO connection. Then we have the agent and large language model imports. So we have an adapter to convert the MCP tools to LangChain format. We have the React agent that is pre-built and comes with LangGraph. And then we have the Google Generative AI wrapper for the Gemini API. Then we set up our environment. So we basically load the .env file, which is our environment. So you can actually see over here that we have the .env file over here, which is this. And you have a Google and Gemini API key defined over here, which is the same key. We just use two different variables to, handle both options in our code. Then we have a custom encoder, which basically, manages the formatting of our JSON content by checking for a content attribute inside the JSON keys. Then we have the read config JSON function. So this basically reads the MCP configuration JSON. So we actually have the AI language config environment variable. If that is set, we use that config path. If that's not set, we basically check the current directory and we formulate the config path based on the current directory name over here and the AI language config.json file name. So this basically gives us this file path. Then we open whichever file we have selected over here. We open that and we load the JSON. We of course do some exception handling over here to handle any kinds of errors. Alright, so then we have the run agent function, and this basically takes in the query as a string and returns a string output for the UI for our MCP client. So this is very similar to what we have done over here in LangChain MCP client with config.py. The only difference is that the query is an input over here that comes from the UI rather than coming from the function over here itself as a query input, as a user input from the terminal. So basically this connects to all the MCP servers defined in the config file, loads their tools, and then processes this query. Now this is the Google Gemini LLM instantiation. We have used this to specify the model over here. We also use the API key that we are basically getting from the environment variables. And we then set up some other parameters which we have explained over here in the comments. Then we read the config file and we get the MCP servers list from the config file by using the MCP servers key in the config.json. If there are no MCP servers, we just print that, we could not find any MCP servers. Otherwise, we create an empty list of tools, and this is basically in the end going to be used to pass to Gemini or the React agent that we are using, and through that it will basically go to the Gemini API so that it the large language model understands what tools it has available to use. Alright, so we use an async exit stack to basically manage multiple async resources, and then we iterate over each server name and server info in the MCP servers.items. So let's just quickly look at our AI language config.json file, and you can see that inside MCP servers we have two servers, terminal server and fetch. So terminal server is basically the name of one server and fetch is the name of the other server, and everything else is the server info, which basically is the command and the arguments. Now going back, so we now understand we have the server names and the server info in all the MCP server items. Then we basically take one server at a time, we connect to it. We then get the server parameters using the command and the arguments. We use the server parameters to establish an stdio connection to the server, and we get the read and write streams for that connection. Then we use these read and write streams from the connection, and we basically create a client session that we store in session. Then we initialize the session. So, it basically is a handshake or a setup operation that happens using MCP. We then use LangChain's MCP adapter to load the MCP tools from the session, and we save it in the list of server tools. Now for each tool in the server tools, we basically inform the user by printing that, we have loaded this particular tool, and we append it to the list of tools that we have declared above. We then do a final print over here and catch any exception over here, and this is basically done for each server name. In case there were no tools found, we basically do an appropriate print statement over here. We finally create a React agent using the large language model instantiation that we did above and the list of tools that we have basically got from the config.json file after initializing all the servers. So this is our agent, and then we take the query and we invoke the agent with that particular query. We get a response over here, and we then print that response. We print that response after formatting it, and so we basically check for messages in the response dictionary, and if we do find messages, we take them in reversed order. So we want the last message from the AI, and if it has the content parameter, we basically return that content. Otherwise, we basically return that no AI response was found in the message. Finally, we have the main entry point for this function defined over here. Alright, so this completes the client stdio.py file. We finally can look at the AI language config.json file over here. So let's look at the AI language _config.json file. So over here, we've already had a brief look at it, and you have a MCP servers key which has a list of MCP servers defined in JSON format. And we have two servers over here. So we have the fetch server. This is a pre-built server that I got from the GitHub for model context protocols pre-built servers that I found online. And then we have the terminal server. So this is a server that we had created in one of our previous videos, and this is basically used to run commands on the terminal. So that is why we call it terminal_server, and hence the name. And we use both these servers just to demonstrate that multiple servers can be connected to, and we can actually load all the tools from these servers and then use them with our MCP client. So before I move on to running this file and setting it up on the terminal, I'll actually also show you the conversation file. So you can actually see that you have a conversations folder over here with two conversations. So let's open one of them. And this is how we actually save conversations. So it's a list of messages with a sender, which is the user or MCP. Then we have the message, which is hi, and in this case it's a response to this message, which is hi, how can I help you today? And then we have a timestamp over here. At the end, also remember that we are using a logo, so you need to provide a logo.jpg file over here, which is actually going to be loaded onto the client UI and shown over there. For the model context protocol, we need Python 3.10 or higher. So we can actually type which Python 3 and check what we have over here. So we have 3.13 and this should be good. In case you don't have the required version, you can head over to Chrome and search for install Python. Go to the download Python link and click on download Python 3.1, 3.2 or whatever is the latest version over here. Whenever the file is downloaded, you can actually run an installer to install Python. And we have a full video to install Python on our channel over here. I'll put the link in the description if you want that help to install Python. Okay, next we need to set up UV, the package manager, and set up our project and environment. So we can head over to the terminal and write this curl command to install UV. I have this already installed, and in case you have it already installed, you can skip this step. So once you have UV installed, you can actually set up your MCP directory structure. So what I do is that I actually set up an MCP directory in my home folder, and then I set up 3 directories over here: clients, servers, and workspace. In the clients directory, I save all my clients, and I'm going to save the LangChain MCP client over here. In the servers directory, I have saved all my servers, all the pre-built ones that I have downloaded, and all the servers that I made on my own as well. And then I have a workspace folder over here, because if I want the MCP servers to take any actions locally on my computer, I use the workspace folder for any kind of file creation, deletion, etc. So for now, we are going to head over to clients folder, and you see that I already have an MCP client over here. You can actually use the GitHub repository link to check out this MCP client folder, and once you have checked this out, you can actually go inside the folder. Before we do that, we need the Gemini API key. So I'm going to head over to Chrome and I'm going to go to aistudio.google.com. When you reach this site, just click on Get API Key. You of course have to be logged in using your Gmail ID. You can click create API key to create a key. I already have a key created over here, and I can just click this button and copy the key. Do make sure that your API keys are secure. You should not share them or embed them anywhere in the code or in any repository. I'm going to disable this API key after I finish recording this video, so I'm going to just let it remain visible over here. Once you have copied this API key, head back to the terminal and create an environment variables file by typing touch.env and press enter. I already have this file over here, so I'm going to just open this using nano. And as you see, I have defined 2 API keys, Gemini API key and Google API key, and I have pasted my key over here. You can actually write this line over here and paste your key next to it. I have used 2 environment variables, Google API key and Gemini API key, because in my personal project, I like to use the environment variable Gemini API key. However, LangChain expects the key to be present under an environment variable called Google API key. So just to avoid any confusion and allow both of the variables to be used, I actually define the key twice using 2 environment variable names. And you can do the same. For LangChain, you'll need to use Google API key. Press Ctrl X and save the file before exiting it. So now you have your environment file set up. So now we can create a virtual environment, which basically helps us keep our project dependencies separate from all other work that we're doing on our computer. So you can type UV and press enter to actually create that environment. I already have created that, and if you're following along from my previous videos, you would also have this directory and environment created, so you don't need to create it. For everyone watching new, please create this environment. Once you have this environment created, you can actually activate it by typing source.venv/bin/activate. And this basically makes you enter the MCP client virtual environment. Okay, so now we are going to add some packages that we'll need to develop our MCP client. These packages are LangChain, the LangChain MCP adapters, LangGraph, LangChain Google Gen AI package, the Google Generative AI package, and the Python.environment package for the environment variables. After writing UV, add, and the list of packages, press enter. And I already have these installed, but you will take a few seconds or a few minutes to get this installed. Alright, so once you've added all these packages, you need to add the other packages for specifically Streamlit and the UI that we are building. So we're going to add the Streamlit package from the file. We're also going to add nest_async.io, and we're going to install Pillow as well. So these are the 3 additional packages that we want to install. Alright, so just type uv add Streamlit nest_async.io and Pillow, and this is going to install these 3 packages as well. Alright, so this installs all the dependencies for your client. Now we are using 2 servers. You can use any servers that you want. In case you want to use the servers that I have used, you can actually look at the previous videos. Let me show you the videos right now. So go to our channel and go to playlists, and then find the Model Context Protocol playlist over here. And you can look at this particular video on building an MCP client with Config.json. To run the UI, we type Streamlit run Streamlit_client UI.py. And this is basically going to launch the UI for us. I'm going to add the link in the description for the other video on the terminal server and the fetch server for you to use if you'd like to do that. And there's also the link for the GitHub repos to pull the code for the servers and for this particular client, so that you can check out the code on your own computer. Thanks a lot for watching. If you liked the video, please do like and subscribe to my channel, and I'll see you in the next video.